We hope you enjoyed playing the game. We certainly did, so we played for lots and lots of rounds. These are our results. We would expect your results to look fairly similar, although because you played for fewer rounds, it's possible yours will be different. The results of our game start to give us an answer to our question. We found that criminals in a mainly honest population, meaning those who stole while everyone else foraged, mostly did better than the honest penguins. Honest penguins in a mainly criminal population, however, did better than criminal penguins. In a population where half of all penguins are criminals and the other half are honest, we found that there was little difference in the average number of rocks each penguin collected. So it seems that how good a strategy stealing is depends on what the other penguins are doing. Also, our results show that a mainly foraging population did better overall than a mainly stealing population. Can we take this idea further? Can we use it to predict how many criminals we'll get in a penguin population? Let's start by thinking about life as a penguin in a completely honest population. What should we do? We know that we'll meet an honest penguin every time, and our results show that in an honest population, criminals did better. So it seems best to turn to crime. What about a completely criminal population? We know that we'll meet a criminal penguin every time, and our results show that a criminal population, honest penguins did better. So in this case, it seems best to forage. However, when we play the game, we don't actually know what everyone else will do. So what do we do? Well, we can write down some maths to express what we predict we'll get. If I decide to be an honest penguin and I play forage, I'll get 1 rock every time I meet an honest penguin and lose 1 rock every time I meet a criminal penguin. If I decide to be a criminal penguin and I play steal, I'll get 2 rocks every time I meet an honest penguin. But I'll also lose 2 rocks every time I meet a criminal penguin. So how does this help us answer our question? We know that the best thing to do depends on what the other penguins are doing. So penguins will be changing their behavior in response to the behavior of other penguins, changing the proportion of criminals in the population. Will this proportion ever stop changing? Or if you think of it in another way, in what situation does it not matter whether we are an honest penguin or a criminal penguin? The answer is when the number of rocks we predict we'll get is the same for both strategies. But we've just written down equations for these predictions. So all we need to do now is to set them equal to each other and solve to figure out what proportion of criminals to honest penguins there should be. When we solve that, we see that it will not matter if we decide to forage or steal, when the chances of meeting a foraging penguin are the same as the chances of meeting a stealing penguin. In other words, when half the population are foraging and half the population are stealing. So we predict that in time, half of the population will be criminals. Let's look back at our question. Why aren't all penguins criminals? We see that by using our model, we've been able to answer that. Mathematical models are a great way to make good predictions and to find answers to difficult questions. It may have been fun to travel to the Antarctic and watch penguins build their nests, but we would need to watch over a whole population of penguins for a long period of time and count each and every time every penguin foraged or stole. It can be much easier to create a simple mathematical model to effectively predict what would happen. In this way, we can use models to investigate a lot of different questions in biology. This is actually what we do here at Complex at University College London. We use models to look at everything from baby brains to the distribution of trees in the rainforest. Now we'd like you to have a go. This summer we are running a competition. A number of different schools like yours are taking part. A team from each school will create a game which models a biological question. The best 3 teams will win prizes. Please ask your teacher for details if you would like to take part.